In this video, I'm going to talk about the basic instrumentation of high-performance liquid chromatography. Now, this high-performance liquid chromatography, these instruments will be found in pharma companies or food testing labs, and there are various uses of these instruments for protein analysis, vitamin analysis, pesticide residue analysis, impurity analysis. So I'm going to just talk about the basic instrumentation of HPLC so that you can identify and you are aware about the parts of this instrument. Now, as you can see on the screen, this instrument is called High Performance Liquid Chromatography. Now this HPLC, it can be divided into 5 main components. First is the solvent delivery system. Second is pump. Third is the autosampler. Fourth is the column compartment. Fifth is the detector. And sixth, that is not really a part of your HPLC, but this PC is attached to the HPLC so that whatever signals are generated, it is sent to your PC and it can be recorded there. Now let's learn about how actually is the flow of the instrumentation of HPLC and a little detail about it. Now, as you can see, the first component that comes here is an HPLC solvent. Now, this is the liquid phase in the instrument, and the stationary phase in this instrumentation is nothing but the HPLC column. Now, what happens is the HPLC pump will help you pumping this liquid phase throughout the instrument at a continuous flow of whatever command you have given to the instrument or whatever is fed in the method. Say 1 ml per minute. It will help in passing this liquid phase throughout the instrument. Now, second thing that you can see here is the injector. Now, the role of the injector is to inject a particular liter of microliter of your sample along with the mobile phase into the HPLC column. Now, as I have told you, the HPLC column is your stationary phase. Now, this HPLC column is embedded with silica gel, and according to the nature of the analyte, depending on its polarity and solubility and the nature of the stationary phase, the separation takes place. And whatever analyte comes out, elutes out of the column first, is detected in the detector, and it sends signals to your computer and it gets recorded there. So this is how is the flow of an HPLC. Now there are 3 terms when you learn about chromatography. These 3 terms can be confusing. The 3 terms are chromatography, chromatogram, and a chromatograph. Now let's learn about what is chromatography. Chromatography is nothing but the technique for separation that is used to separate the mixture of compounds. Now there are various chromatography techniques. It could be ion exchange chromatography, it could be size exclusion chromatography, it could be gas chromatography. There are various techniques of separation of the mixture of compounds. Now second term that comes in picture is a chromatogram. Now chromatogram is nothing but the result that is obtained on the recorder. The peaks that are obtained on the screen after the signals have been transmitted. that is a chromatogram that is generated on the screen is called a chromatogram. And the third term that is used is a chromatograph. Now the chromatograph is the instrument that is used to conduct the chromatography. Now HPLC is a chromatograph, GC is a chromatograph, gas chromatograph, high performance liquid chromatograph. Now these are the instruments. Let's learn more about the solvent delivery system. Now, as you can see, there's mobile phase bottles, there's a degasser, there's a pump. Now these together makes a solvent delivery system. Now in an HPLC, mostly there are four ports, four mobile phase ports, A port, B port, C and D port. Now mostly A and B port are used, wherein A port is mostly used for storing aqueous phase liquid. It could be 100% water or any buffer can be used. Mostly if you see, aqueous phase is used and it is pumped through mobile phase A port. And in mobile phase B port, mostly organic phases are used, that is for ACN or methanol, and that is dedicated ports. And one more thing that you can see here, the ports, there's a rectangular shaped uh, object that is called as frit. Now, what is the role of the frit is that it will help in filtering the liquid before it goes through the HPLC system. Now, this HPLC system, it is all about tubings and all, and these tubings have a very minute pore that is around 0.45 micron size. So if there is any dust particle that enters the tubing, it could block the whole instrument. So it is necessary that we filter the mobile phase that is being entered into the system. So this frit helps in filtering. Yes, externally also we filter the mobile phase that is brought to the instrument. But again, for safety precautionary measures, we use a frit so that the mobile phase that is being pumped is filtered. And after the mobile phase is being pumped, it enters the pump. Now you can see there is a degasser that is separately drawn, but actually the degasser is inside the pump itself. And this degasser, or what is the role of this degasser is that it helps in removing all the dissolved gases inside your liquid phase. Now, why do we have to remove the dissolved gases in the liquid phase? What would happen is that it would affect the retention time of the peak. Now, suppose if, example, a caffeine peak is coming at 1.5 minutes. The retention time is 1.5 minutes, but because of this dissolved gas, say this caffeine peak which had to come at 1.5, it got shifted to 2 minutes. So these dissolved gases can help in these dissolved gases could hinder your experiment and the retention time won't be robust. So if you want robust timings that caffeine peak should be eluted at 1.5 minutes, then it is necessary that the liquid phase should be free of any dissolved gases. An autosampler in HPLC, it is a device that automatically injects a precise amount of sample into the HPLC. Now this helps to increase the speed and accuracy of sample loading, because it is in an auto sampler we don't have manual injection of sample involved over here. So the autosampler, it picks a precise amount of sample from a vial using a syringe. The sample is delivered to a sample loop afterwards, and the injection valve introduces the sample into the mobile phase flow path. The sample is separated then on the HPLC column. Now in the HPLC instrument, there's this column compartment, and this column compartment can be temperature regulated depending on the method, like if the analyte is best separated when the temperature given to the column is 35 degrees Celsius. So that is how we can regulate the temperature inside the column compartment, so that the separation of the analyte is efficient. Now inside this column compartment, there could be any column, like it could you could use a non-polar column or a polar column, whichever is best suited for that experiment. Now what happens is when the injector, it loads a particular mul of sample onto the column. So along with the mobile phase, this mixture of analyte, it mixes with the mobile phase and it enters this column. Now this column could be polar in nature or non-polar in nature. So depending on the polarity of the analyte, this continuous separation that is happening. This mixture of compounds, you can see it will be getting separated depending on the nature of its polarity. Now, if the column that is used is non-polar, so it will interact with the non-polar analyte more, and it will help to retain this non-polar analyte on the column for a longer period of time than as compared to the polar analyte. This polar analyte will have very less interaction with the column because it is polar. So it will repel this particular analyte who is polar in nature. So as a result, the polar analyte will elute out of the column first and followed by mid-polar analyte, and at last when you change the mobile phase component, when the mobile phase is more non-polar in nature, that the non-polar analyte which is interacting with your column, it will get replaced, and thus the last analyte that is non-polar, that also gets eluted. So this is how the principle, the separation of the analytes works. Now in an HPLC, the role of the detector is to identify and measure the components of a sample as it passes through the HPLC system. Now there are mainly three types of detectors present in an HPLC instrument. Various detectors can be used, that is diode array detector or a refractive index detector or an FLD detector. But widely, DAD detectors, that is UV visible range detectors, are used. So what happens? This DAD, it works on the principle of Beer-Lambert's law. It is that the light source, it emits particular wavelength, and this wavelength is then emits the solution that is present, that has to be measured. Now there are various components of analyte that can be present in this solution, and this light, when it hits this solution, it absorbs a particular amount of light, and then the remaining, it will hit the detector. So as we know, the Beer-Lambert's law is that the sample concentration is directly proportional to the light being absorbed by the solution. So this is the principle of DAD detector.